Welcome back to basics. Before you understand momentum correctly, you need to know how to solve basic vector questions and understand how they work. In momentum and impulse questions, you will learn about vectors, and using them correctly is all about direction. Pay very close attention to the direction when dealing with vectors of any kind. They are the most common area where things go wrong in calculations. Remember that vectors are numbers that also have information about direction. It's important for some quantities to have information like direction added to them. So, a vector is a thing we can measure that has both magnitude and direction. Magnitude is a scientifically correct way of saying how much of something we have. The direction is simpler, but we need to make it clear and relevant to the question. North, upwards, to the right, or even in the original direction of motion would be appropriate, depending on the example. So, some examples of vectors that we've used up to now are displacement, velocity, acceleration, force. They all have a magnitude, unit, and a direction when they are shown fully. Something interesting happens when you use vectors to calculate other vectors. Often, the new number that comes out can become a vector itself. So, direction is really important. How do we show vectors in a visual way that shows size and direction? Well, an arrow can be long or short, and using the pointed end, it shows where the vector's direction is. See, if there were several forces on the airplane of different sizes and directions, an upward force of 10,000 newtons, a downward force of 10,000 newtons. The engines apply a forward thrust of 8,000 newtons and drag of 7,000 newtons. See how the directions and magnitudes are important. The upward and downward forces are the same, meaning that the aircraft isn't accelerating up or down. But, since the forward force is greater than the reverse force, there is an excess of 1,000 newtons forward. But let's do it properly. How do we do this mathematically? It's actually easier than you think. We talk about direction in a straight line, so only the vertical or horizontal. So each needs its own positive direction. This is chosen by you. So if we talk about vertical forces, let's make upwards positive and downward becomes negative. So now we can add the two numbers. Positive 10,000 plus negative 10,000 equals 0. There is no net force acting vertically and the aircraft keeps flying horizontally. What about the horizontal vectors? Let's take the forward direction of travel as positive. That means that the vectors have values of positive 8,000 and a reverse vector. This makes it negative 7,000. Now, when we add the vectors, we get positive 1,000 newtons. The positive part is really important. It actually tells us that the net force is in the forward direction. So when we write out the vector's answer, we also indicate the direction. So F net is equal to 1000 newtons in the forward direction. Be careful about using left or right, because those depend on our point of view. The front of the aircraft is always the front. What about these two people running in the opposite direction towards each other? How do we indicate their velocities as vectors? It's really important that we use the same positive direction for both of the people in the example. This matters a lot when we start to use the velocities in other calculations. So let's take the original direction of the girl in the picture as a positive direction. How do we show their velocities? The girl's velocity of movement will clearly be positive 3 meters per second, while the boy's will be negative 5 meters per second. The negative is very important if we are to use it in calculations. So, what about calculations done with vectors? The signs are super important. If we use a vector like the example shown, watch what happens when we apply a velocity to a simple displacement question. Let us choose a positive direction and mark it on the diagram with an arrow. What is the final position of a person initially at 40 meters from a point A when they move at 1.5 meters per second back towards the original point for 50 seconds? So, when someone starts at a positive position of 40 meters, that means that they are 40 meters in the positive direction. So, if they are walking to the left in the picture at a velocity of 1.5 meters per second for 50 seconds, let's use the basic calculation for average velocity, but let's make sure that the velocity has the right direction. If we substitute in negative 1.5 meters per second into the equation, when the initial position is positive 40, the final position comes out to be negative 35 meters per second. That is very important. It tells us that the final position of the person is negative 35 meters in the negative direction. Remember that we need to write out the final vector displacement with a direction. So the final position is 35 meters in the negative direction.